Hello everyone, this is Dr. A, and for today we're going to be working on functions and relations in algebra. In algebra, we have such a thing as relationship and functions, and that's what we're going to be working on in some of the problems that we will be working on or seeing in our lesson for today. But first, let's identify the different types of functions that we will encounter in algebra and even in trigonometry or geometry all the way to calculus. And these type of functions will help us understand mathematics better, knowing that our function can come in many forms and sizes. So one of the most popular ways on how we represent functions in algebra is function in algebraic form. So we are seeing f of x is equal to 2x cubed plus 3x minus 1. And this is a function given by an equation. And sometimes our f of x, or notation f of x, equal to 2x cubed plus 3x minus 1 can throw some students off, but if we represent a function or equation as y is equal to 3x cubed plus 3x minus 1, most students will understand it better. But remember that in mathematics, we need to understand different notations, and in this form, we are just saying that our function can be represented in many different forms. So one way of showing a function in equation form is by using f of x in replacement with the value of y. So if our function can be in an equation form, it can also be in table form. So that means input, output, just like our equation. The value of y is dependent on what is our input, which is the value of x. So in this case, if x is equal to negative 3, then f of x, or your y value, is equal to 0.23. And if x is equal to 9, your y value, or your f of x, is equal to 3.4. So this is how we represent function in table form. And the last form that you will encounter in mathematics would be function in graph form. So these are the three types of representation of a function in mathematics, and all of them are holding the basic idea of input and output. And that's what we're going to be learning today, and we're going to be seeing relationship in a different light. So in mathematics, a relation is a set of ordered pairs. So ordered pairs are x and y coordinates that we commonly see in most of our math lessons, and we are often hearing the domain and the range of a function. Just remember that the domain is the relations, or the domain of the relation is the set of all x coordinates. So if the x coordinates is our domain, our y coordinates would be our range. And this is how we represent relationship in functions mathematically. We have the input and we have the output. We have the domain and we have its range. So if we're going to be determining the domain and range of this relation, knowing that our function is in ordered pair or in pairs of numbers like this, we know that our domain would be the x variables. So we'll have the first ordered pairs, which is the x coordinates. So we'll have 4, -4, 2, and 10. And for our range, which is the second coordinate, would be the y values, and we have 9, 9, 3, and -5. Now, notice that we have a duplicate of 9 in our range, and to be able to identify our range, we need to eliminate duplicates. That's why our range is just going to be 9, 3, and -5. So this is how we identify the domain and the range of a function. It's pretty simple when we are presented with ordered pairs like this one. So if we're going to determine the domain and range of this particular relationship, wherein the domain would be our input, and our input in this case would be the types of animals in this column, we have polar bear, cow, chimpanzee, giraffe, gorilla, kangaroo, and red fox. And on the other ordered pair would be our output, and our output would be their lifespan. So there's 20 years, 15 years, 10 years, and 7 years. And how are we going to map this relationship? So for polar bear, 20 years. For cow, 15 years. For gorilla, it's also 20 years, and so on. So this is a type of relationship because we have an input and an output, the domain being all the animals, and the range being the lifespan of those animals. So if we're going to write the domain of this function relation, the domain would be the animals, and the range would be their lifespan. So this is how simple identifying our domain and range when we are given unordered pairs or input and output or functions in table form. Now, one thing that we need to know about functions is that sometimes function cannot always be considered as a function depending on the type of relationship that we are seeing in our algebraic problems. So some relations are also functions, and how are we going to identify it? A function is a set of ordered pairs that assigns each x value to exactly one y value. So keep that in mind, one x value mapped to exactly one y value. And how are we going to show this type of validity of a function in an f of x or in algebra? Let's have an example similar to what we had a while ago. So we have 4, 9, negative 4, 9, 2, 3, 10, and negative 5. So if we're going to list down the domain of this function, we have 4, negative 4, 2, and 10. And for the range, we have 9, 9, 3, and negative 5, which is basically the x variable and the y variable. However, notice that in our range, we have duplicates, and we have 2 9s in our range, so we're going to eliminate the duplicates, giving us 9, 3, and negative 5 as our range. And going back to our relationship, we have 4, 9, negative 4, 9, 2, 3, and 10 and negative 5. If we're going to map it to our domain and range column, 4, 9, 4, 9, negative 4, 9, negative 4, 9, 2, 3, 2, 3, and 10 and negative 5, 10 is 2, negative 5. And we are seeing that we are only mapping one x variable to a y variable. So even though 9 is mapped to 2 of your x's, this is still considered to be a function because the basic premise is that one value of our domain should be mapped to only one value of your range for it to be a function. So when this condition or this situation happens, we know that this is still considered to be a function. So the first thing that we need to do is to write our domain on one side of the column or one side of our sheet of paper, and then our range of values, 9, 9, 3, and negative 5. Knowing that we have a duplicate, we need to get rid of that and start mapping our relationship based on our ordered pairs. So 4 is to 9, negative 4 is to 9, 2 is to 3, and 10 is to negative 5. And this is still considered a relationship, or this relation is a function because of the basic rule that only one x should be mapped to only one y. Now let's have another example and let's see if this relationship can still be considered as a function. So we have all the domains 3, 7, 3, and 8. So 3, 7, 3, and 8. And for our range, we have 8, 2, 5, and 7. 8, 2, 5, and 7. And notice that in our domain, we have duplicates, and we need to get rid of that. So we're going to get rid of one of the 3's. And by doing so, we'll be able to see if this relationship or this function is still a valid form of a function basing on our definition. So let's start mapping. So 7 is to 2, 3 is to 8, 3 is to 5, and 8 is to 7. Notice that our domain, or one of our domains, which is x is equal to 3, is mapped to two values of y. And when this happens, now we can say that this relation is not a function because it defies the basic definition of function relationship in mathematics. So to make sure that you will remember how to identify if our relationship is a function or not, it is okay for a y value to be assigned to more than one x value, but an x value cannot be assigned to more than one y value. Talking about double standard in mathematics. So that's basically how it is. The x can be mapped, or the x can only be mapped to one y, but your y's can be mapped to multiple x's and still be considered as a function as long as all the x's are only mapped to one y in your relationship. So that's what you need to remember when you are given a table form or ordered pairs as form of relationship in your f of x or function. Now, we have such a thing called the vertical line test because, as I've mentioned, a function can be represented by a table or ordered pairs, and it can be also represented with a graph. And when your f of x is represented by a graph, we're going to be using the vertical line test to check if the relationship of that function is indeed a function or not. So what is a vertical line test? If a vertical line can be drawn so that it intersects a graph more than once, then the graph is not the graph of a function. So that is basically what you need to do. So let's say you have a vertical line, a ruler, pass it through your graph or f of x. If your graph intersected to your vertical line twice, then it's not a function. So let's take a look at this example. So we are seeing a linear function, a diagonal line, and notice that if we pass our vertical line through our f of x, like so, this is our vertical line, and it will pass through our graph, it will only hit our function once. So that means this graph or this function is indeed a function because the vertical line test verified that you only have one point of intersection of your vertical line to your graph. So that's what you need to remember. It's pretty easy actually when you are seeing a graph because you don't need to pair or to see the pairings of your ordered pairs. All you need to do is to use a vertical line and pass it through the graph and see if it will pass through the graph once. Similar to the second example. And in this example, we are seeing an ellipse. And in this ellipse, if we use our vertical line test, notice that our vertical line is now intersecting our graph twice. So since it's intersecting our graph twice, now we can say that this function in graph form is no longer a function because you have 2 points of intersection in your vertical line. And for the last graph, we have a parabola opening upward, which is a quadratic function. If we use our vertical line test and pass it through our graph, we know that even though we pass it all the way through the right side of your function, it will only intersect your vertical line once. That's why this is a graph of a function and it's a valid function. So those are the two types of, or two ways on how to identify function relationship in algebra. One, using mapping method, and two, using the vertical line test. But what if our function is now an equation and not an ordered pair or a graph? Then it will become a little bit challenging because we need to be able to visualize the graph of the function so that we would know if we can use the vertical line test for this problem. So we have a linear equations, y is equal to x, y is equal to 3x minus 2, y is equal to 6, and x is equal to 4. The y is equal to mx plus b is one of the formula that we use to graph a function. So if we have y is equal to mx plus b, where m is the slope and b is the y-intercept. It's supposed to be plus, y is equal to mx plus b, not minus. And we'll be able to know our graph because let's say your graph is y is equal to 2 over 3x plus 1. To graph it using the slope-intercept form, our y-intercept, which is 1, this is 1. We place our first point on 1, and our slope is 2/3. That means 2 up and 3 to the right. 1, 2, and 3 to the right. And then that point determines the slope of your line. So this is now a linear function. And if we use a vertical line test, we know that it will only pass through the vertical line once. So 2/3 x plus 1 is a function. So that is how we're going to identify a function if we are given an equation. A little bit challenging, but it's still doable. So let's start with the first one. Y is equal to x. So that means our slope is equal to 1 and our y-intercept is equal to 0 because there's none. So that means if we graph this, the y-intercept is at 0 and the slope is 1, which means 1 over 1. You up 1 and you go over 1. And this is still a linear function. And using a vertical line test, it passed our it passed our vertical line test method. So that means y is equal to x is a function. So that's how we use this method to identify if a relationship is a function. So moving on to the second one, we have y is equal to 3x minus 2. Graphing it, y-intercept is at negative 2, 1, 2. Our slope is 3 over 1, so that means 1, 2, 3 over 1. And this is still a line. And if we graph a vertical line right here, there's only one point of intersection. That means this is a function with a slope of 3 and the y-intercept of negative 2. We know that this is a function. So what about y is equal to 6? Y is equal to 6. We know that our m here is 0 because our x variable is not existing. And our y-intercept, which is the constant, is at 6. So that means if we graphed it, m is 0, y-intercept is 6, 1, 2, 3, 4, 5, 6. So y on 6. And since it's a constant 0 or slope is 0, that means we have a vertical line because any values of your x could be 1, y is still going to be 6, x could be negative 2, and y is still going to be 6. So that's why we have a horizontal line. So that means with the vertical line test, there's only one point of intersection, so that means this is a function with a slope at 0 and y-intercept at 6. And lastly, we have x is equal to 4. And notice that x is equal to 4 is not of the form y is equal to mx plus b. And when that happens, if we graph it on our xy plane, if x is equal to 4, this the x-axis, 1, 2, 3, 4, it's only going to give you a vertical line. So using a vertical line test, if we draw a vertical line right here, we know that there is not just one point of intersection, but infinitely many intersections. So that means this failed our vertical line test. So D is the only one that is not a function in our equation. So that is why identifying relationship in a function can be easy if it's given by an ordered pair or a table or a graph form. But when your f of x is an equation, that's when the challenge is going to lie. So all you have to do is to know your techniques on graphing. And one technique in graphing that we can do is modeling, which means we are going to be assigning our x values and see what our y values is by substituting it to the value of the function. So how are we going to use that? Given this form. So know that y is also f of x, or read as f of x or a function of x in our math notation. And in this notation, it only means that y is a function of x, or that y depends on x. That is why y is called the dependent variable. Y is the dependent, and the x is the independent variable. So that's what you need to remember about dependent and independent, because y is determined but by the values of your x. That means y is a dependent variable. So x can stand on its own, but y, its value is dependent on what your x value is. So that's why if we have y is equal to 3x minus 5, or f of x is equal to 3x minus 5, our x, which is our domain, is our independent. We assigned it. So we have negative 1, 0, 1, and 2. And our y value, we're going to figure it out. That's why it's dependent. And to figure it out, we are just substituting the value of your x to your y. So for the first ordered pair, if x is equal to negative 1, y is equal to negative 8. So our first ordered pair would be negative 1 and negative 8. And if we continue, if x is equal to 0, y is going to be equal to negative 5, because 3 times 0 is 0, and 0 minus 5 is negative 5. So we have 0 and negative 5. And if x is equal to 1, 3 times 1 is 3, minus 5 is equal to negative 2. So we have 1 and negative 2. And if we have x is equal to 2, 3 times 2 is 6, minus 5 is going to give us 1. So our last ordered pair would be 2 and 1. So this technique is what we call as modeling, and it's also another way of graphing to check for the relationship of your function. And now that we have our ordered pair, we can map it or we can graph it. So let's graph it. So by using the xy plane, we have the first point at negative 1 and negative 8, and then 0 and negative 5. And x is 1 and y is negative 2 is right there. And the last ordered pair, 2 and 1 on the first quadrant. And if we use a line, this is going to be a linear function. And we know that using a vertical line test, it will only pass through the function once. So this is indeed a function. And also remember that our domain, or our x variable, is our independent variable, and our range, or the y variable, is our dependent variable. So that is why when I mentioned on the first few minutes of our lesson, function in algebra is like a machine, input and output. Your input will be your x, and your output, or your result, is your y. That is why the Numberbender challenge of the day is to identify if this function represented by this graph is indeed a function, knowing the skill that you have learned in our lesson today. So comment it down below and give me the reason why you think this is a function, or why you don't think this is a function. And this is our lesson for today in algebra. So remember that in mathematics, there are 3 ways on how to represent a function. It could be in equation form, table form, or in graph form. This is Dr. E, and see you again next time. Bye!